In this video, you will learn to derive the sum and difference identities for the sine function. We will begin by looking at the cofunction identity, which states that sine of theta equals cosine of the quantity pi over 2 minus theta. Next, we will let theta equal a plus b and substitute a plus b for theta into the cofunction identity, giving us sine of the quantity a plus b equals cosine of the quantity pi over 2 minus the quantity a plus b. Next, use the associative property to regroup the terms in the cosine expression, giving us sine of the quantity a plus b equals cosine of the quantity b subtracted from the quantity pi over 2 minus a. Next, expand using the difference identity for the cosine function. This gives us sine of the quantity a plus b equals cosine of the quantity pi over 2 minus a times cosine of b minus sine of the quantity pi over 2 minus a times sine of b. Cofunction identities can then be used to change cosine of the quantity pi over 2 minus a to the sine of a. Similarly, we can change sine of pi over 2 minus a to the cosine of a. Using these identities allows us to simplify the equation to sine of the quantity a plus b equals sine of a times cosine of b plus cosine of a times sine of b. We have now derived the sum identity for the sine function. We will now use the sum identity and the properties of even and odd functions to derive the difference identity for the sine function. Begin by replacing b with negative b in the sum identity, which gives us sine of the quantity a plus negative b equals sine of a times cosine of negative b plus cosine of a times sine of negative b. Next, use even and odd identities to simplify, which gives us the difference identity of sine of the quantity a minus b equals sine of a times cosine of b minus cosine of a times sine of b. Now that we have derived both identities, let's look at an example where the difference identity is used. Graph the function y equals 2 times the sine of 3x times cosine of x minus 2 times the cosine of 3x times sine of x. If we apply the difference identity, we can rewrite this equation as a single sine function and then graph it. Begin by factoring out the 2 that is common to both terms. Next, write the difference identity for the sine function and identify a and b. In this case, a is 3x and b is x. It is important to note that we are using the difference identity because the original expression, when factored, is in the form defined by the difference identity. Next, we will work backwards. Knowing that the expression sine of 3x times cosine of x minus cosine of 3x times sine of x is the form defined by the difference identity of sine, and knowing that a equals 3x and b equals x, we can rewrite this expression as its equivalent according to the difference identity of sine, which gives us sine of the quantity 3x minus x, which simplifies to sine of 2x. Don't forget the 2 we factored out earlier, and notice that it has been retained as we have made changes to our expression. Thus, we will graph 2 times sine of 2x. Finally, use a calculator or table of values to graph y equals 2 times sine of 2x.